The quantitative business analysis portion of the ETS exam takes up about 11% of the total information that you need to study. The goal of this video is to help you learn and understand concepts relating to this portion of the test. We are going to cover many concepts quickly, so be sure to keep up. Remember, if you can get all of these concepts down, you will do just fine on this portion of the ETS exam. The key information that you need for business analytics can be split into two groups: probability and statistics, and quantitative operations management techniques.
In this section, we will discuss these key concepts: measuring a set of operations, conditional and joint probabilities, distributions, and measures of central tendency and dispersion. Measuring a set of operations. Sets can be combined by different methods called operations. There are two main operations that you will need to know about. These are unions and intersections. A union includes every value that is in both sets, as seen in this Venn diagram. Everything in set A and B is included and everything outside is excluded. Say, for example, we have two sets, set A with values 1, 2, and 3, and set B with values 2, 3, and 4. The union of sets A and B would include values 1, 2, 3, and 4. An intersection operation looks like an upside down U and includes every value that intersects two sets. Using the same sets, the intersection of sets A and B would include values 2 and 3. Conditional and joint probabilities. Conditional and joint probabilities are very similar to measuring a set of operations. The only difference is that they deal with the probability of events instead of sets of values. Assume there are two events and each has a probability. Event A is the probability of you finishing your homework, which is 90%. And event B is the probability of your dog eating that homework, which is 30%. 90% times 30% gives us 27%. That means that we can be 20% sure that our dog will eat our finished homework. In business analysis, distributions can help us visualize the meaning of a data set. With this information, we can easily see anomalies and patterns in our data. A normal distribution is shaped like a bell curve. The curve represents the number of values that fall in that area. Notice how the arc is highest at the mean because the mean represents the average value. On the edge of the graph, there are much fewer data points, and so the curve comes towards the origin. A rule that can help us understand the bell curve is the 68-95-99.7 rule. This rule states that as long as the distribution is normal, 68% of the data will land within one standard deviation of the mean, 95% will fall within 2 standard deviations, and 99.7% will land within 3 standard deviations. But what even is a standard deviation? A standard deviation is a measure of dispersion. It measures how much the values in a data set vary from the mean. It is a standardized measure and can be applied to any data set.
For the second half of the probability and stats portion, I will be discussing these concepts: sampling and estimation, correlation and regression, time series forecasting. A sample is a selection of data, aka a subset, from a larger group of data. This is typically used when the population is too large to research, aka you got too much dip on your chip. There are 4 sampling methods. You have simple random, whereas the subset is chosen at random. You have systematic, where the subset is chosen at an interval. Then there's stratified. The subset is chosen based on similar characteristics, like if you have red hair and constantly get made fun of, or constantly get asked where my pot of gold is. Number 4, clustered. The subset is chosen after the population is divided into clusters and randomly selected into subsets. Then there's estimation. This is the process of using approximated values to create a rough calculation. You're in a grocery store and you suddenly forget how to use a calculator. Oh no! Once you forget how to use a calculator, you start looking at the items that you've bought. Let's say you've bought milk for $2.90. Then you bought some fruit for $1.50. And then you bought some bread for $3.49. You can easily round that up to estimated an $8.50. A correlation is a relationship between variables in a scatter plot. When looking for a relationship between two variables, it is important to find a line of best fit. A line of best fit, or a regression line, helps find a linear correlation. Our general equation for a linear regression line is y equals A plus B times X. A represents our initial value. B represents how steep the overall trend is in the data. Let's say we all measure our shoe sizes and our height. It's safe to say the bigger your feet, well, the taller you are, of course. So based on the data, we can assume a positive correlation or linear trend line in shoe size versus our height. Time series forecasting can help us predict the future trends by using correlation. Using our same shoe example, pretend we replace the x-axis with age. With this new chart, we should be able to predict how big your feet are based on your age.
For the final portion, we will cover concepts related to quantitative operations management techniques. These are project scheduling and inventory modeling. Project scheduling is used to find a plan and to schedule projects, ensuring that time and resources are optimally used. Some tools for project scheduling are the Program Evaluation Review Technique, also known as PERT or PERT, and the Critical Path Method called CPM. The difference between the two is that PERT is ideal for high uncertainty, where task durations cannot be predicted, while the critical path method is more suited for projects with predictable timelines. And an example of a company using the PERT method would be a pharmaceutical company researching or developing a new type of over-the-counter drug. To develop that, and you can't really predict or put a deadline on the development. Critical path method would be more ideal for a construction project where deadlines are put in place to ensure that project is completed in a certain amount of time. The next concept we're going to be talking about is inventory modeling. So the whole point of inventory modeling is to manage and optimize inventory space in general. Some of the techniques / models used are safety stock models, just-in-time models, better known as JITs, and ABC analysis models. Take JITs for example. JITs, not to be confused with the urban term meaning friend or companion, is a model that stands for just in time. Most companies that use JITs are factories or use some sort of assembly line. They use this method because the materials being put together are sent, as the name suggests, just in time. This minimizes inventory, which reduces storage costs and keeps inventory organized.
I hope this video helped you learn more about, or at least refresh your memory, quantitative business analytics concepts. Thank you for watching and good luck on your ETS exam.